We finished the second section in this chapter in the last lecture. We now have Laplace transform of Herbicide unit step function, Herbicide or unit step function. Before we find the Laplace transform of the Herbicide function, it's also called unit step function. Herbicide function and unit step function are the same. Here we have the unit step function. It's the definition of unit step function. We say that the unit step function h of t minus a, this is the unit step function, is defined by f of t equals h of t minus a, and it equals to a piecewise function. It equals to a piecewise function. We say it equals to 0 if t is from 0 to a, and equals to 1 if t is greater than a. Here, this is a. That means if t is between 0 and a, we say the Herbicide function or the unit step function is 0, and equals to 1 if the Herbicide function or the unit step function is greater than a. This is a. For example, let's take an example. If we have h of t minus 4, let's say, it equals to 0 if t is greater than or equal to 0 and less than 4, and it equals to 1 if t is greater than or equal to 4. Yes. No. هنا دانا نقشه که Herbicide function بشوي piecewise function using أو نقشه بشوي. Okay, and the graph is from 0 to a, it is 0, and for greater than a, it's 1. Go on. Okay, we also have step function and unit step function. The unit step function is this one, is this form. This is unit step function. And also have step function. We have step function and unit step function. The above one is unit step function or Herbicide function. To convert step function to unit step function and vice versa, first we should know what is the step function. We say a step function is a piecewise continuous function. This is the step function. This function is called a step function. This function is called a step function. But if you write down for h, this is the unit step function. So the step function is the piecewise function, is a piecewise function, but the unit step function is the function for h. Let's see this in this example. Here we have given a step function. This is not unit step function, it's a step function. G of t equals g1, where t between 0 and a, and it equals to g2, where t is greater than a. This is a step function. This is a continuous piecewise function, and this function is called a step function. To convert this to unit step function, if we compare this to unit step function, we say it equals to g1, the first one, g1, plus g2 minus g1 times h of a, h of t minus a. This is if we have only two functions in the piecewise function. So if you have more than two functions in the piecewise function, let's take an example. If we say g of ax to be, let me write down below. If g of ax equals, let's say g1, g2, g3. Here we say where t is less than, let's say, 2 and greater than or equal to 0. And here 2 less than or equal t less than, let's say, 5, where t is greater than 5. If you have three functions in the unit step function, in the step function, sorry, to convert this unit step function to convert this step function to unit step function, what we do? We say we first write down the first function g1. We say g of t equals g1 plus g2 minus g1, g2 minus g1 times h of t minus 2. We take the below one, okay? T minus 2, then plus, then g3 minus g2, g3 minus g2 times h of t minus 5. That's all. Okay. هي دالين شيء. سرتها نقشية كم نسي؟ انجارين. نقشيس دوم ناقص نقشية كم؟ h of t ناقص ليه أمش مالك هماني بس. لا أبي أقول g2 ناقص شو؟ جودة كناقص شو؟ أوكي؟ ليه؟ دي سان ايش النقشية كم؟ g c شنو؟ على g c ناقص g2 h of t ناقص أو شمارين. Let's take 4 functions. Okay, if you have a step function for 4 functions, I'm going to write down here, then I clean it because here it's the space for an example. If we have, let's say, g of t, if g of t equals g1, g2, g3, and g4. Here, for g1, if t is less than, let's say, a, greater than or equal to b, to 0. Then here, t is less than b, greater than or equal to a. T here is less than c, greater than or equal to b. T here is greater than or equal to c. We have this step function. G is a function. G1 is a function. G4 is a function. G1, G2, G3, and G4. These all are functions. Sorry? No, you can do it for n functions. I'm going to write down the rule for 4 functions. Okay? We say g of t, this is the step function. This is step function. The unit step function is the one which I am going to write down now. G of t equals, this is the unit step function. Let me write down above here to write all together. G of t equals, first we write down g1 plus g2 minus g1 minus g1 times h of t minus a. Okay, t minus a, then plus, we found this one, and then g3 minus g2 h of t minus b plus g4 minus g3. Okay, times h of t minus c. That's all. So if you have 5 functions, we have one more. Okay, that's all. This is how to convert a step function to a unit step function. Now we have an example. In this example, it says express the following function in terms of unit step function. This is a step function. We must convert this to unit step function. I'm going to clean this one, okay? It exists in the record, so you can take it from the record. Have you got the idea how to do it? Now we have this example. So what's G1, what's G2, what's G3? The first function is G1. This is G1. G2 is T. G3, sorry, this is G2. And this G3. G3 is 0. We say to write down this in form of the unit step function. We say f of t equals, you have f of t, so you write down the same. F of t equals g1. G1 is t minus 4. You say t minus 4. Let me write down the rule first. You say f of t equals g1 plus g2 minus g1 times h of t minus a. What's a here? It's 2, the previous one, plus g3 minus g2 times h of t minus 4. Okay?
So value 6 minus 2, minus 2, h of t minus 2.
Look, what's common between g1 and g2? 2. That's how you say it that way. And what's the common between these two? 4. That's how you say that. Okay? Now we say f of t equals g1. G1 is t minus 4 plus g2 is t minus g1. G1 is t minus 4 times h of t minus 2 plus g3 is 0 minus g2 is t times h of t minus 4. And this equals to t minus 4 here, t, and if we enter this negative sign, we get minus e. These two are cancelled, you get 0, and you get 4, it's plus 4 t minus 4 plus 4 h of t minus 2 here, t minus 4, here we just get 4 because t and negative t are cancelled out, we get only 4 h of t minus 2 plus we get 0 minus t is minus t h of t minus 4. This is the unit step function for the given step function. You don't, no, use nothing. If these two are equal, you can, but it's never be equal. That never be equal. Sorry? This is the simplest form. Because here you have h of t minus 2. Here we have h of t minus 4. And here you have no h of h function.
Sorry, what is h?
H is the heaviside function. H here, for this one, we say it equals to a piecewise function. It is 0 when t is greater than or equal to 0 and less than 4. And it's 1 for t greater than or equal to 4. It's that.
I mean, in real.
In real life?
In this equation, what's the purpose of h?
H is this piecewise function. It's that. It's defined by h of t minus 4.
So
there is more than that. We can use a piecewise function. No, you cannot change to that. How do you change these limits? No, it couldn't be changed to the previous one, to this one. These two are not equal, so you just leave it the same. So this is the simplest form of this unit step function. Now we have a unit step function. We should convert it to step function. That means from this we must take the piecewise function. How? This is G1. This is because here we have no h of t minus something. This is G1. And the second is G2. This is G2 minus G1. This coefficient. This is G2 minus G1. Yeah. And this is G3 minus G2. Here we can find G1, G2, and G3. So first, let's write down the form of the piecewise function. We say G of, here we are, f of t equals G1, G2, G3. We have three functions. We have three G functions. For the first one, t is from 0 to 2, because you have h of t minus 2. And the second, t is from 2 to 4, because there's t minus 4. And then for the last one, t is greater than or equal to 4. We have these are the limits. Now we should find the functions of G1, G2, and G3. How? G1 is given as t plus 1. G1, we say G1 equals t plus 1. So this is t plus 1. Now to find G2, we say G2 minus G1 equals to 1 minus t. That's it. Here we have given this function, which is the coefficient of h of t minus 2. We say this is G2 minus G1. Is it? It's G2 minus G1. So G2 minus G1 is 1 minus t. But we have G1 also. We just replace by the function. We say G2 minus t plus 1 equals 1 minus t. We just replace G1 by the function, which is t plus 1. And G2 minus t minus 1 equals 1 minus t. That means G2 equals 2. Is it? Here, we move these two to the other side. We get t and minus t. These two are cancelled, and you get 1 and 1, which is 2. So G2 is 2. We have G2 now.
I mean, I don't know.
Two. بس الأمر أبو. هسه تيجي تشتري شنو؟ Now, we find G3, but we know G2. G2 is 2. We found this. We say G3 minus G2 equals t squared. Okay. We found G2. G2 is 2. We say G3 minus 2 is t squared. That means G3 is t squared plus 2. So here you say G3 is t squared plus 2. This is the step function. That's all. Here, it's just finding the limits, I mean the intervals, and also the functions. You have given G1. From G1 you can get G2, and from G2 you can get G3. Okay, because there is a relationship between G2 and G3. Second, ليه شيء شيء دوسني G. لا لا ما لا Look, it depends on this. If there is no S function, means it is G1. Okay. Among those, which includes S function, take the smallest value of A to G2. For taking G2 minus A, I mean the coefficient of h of t minus 2 is G2 minus G1. And this one is G3 minus G2. Why? Because this is greater than 2. Okay, so if, let's see. If you have given t squared minus 2 plus t minus 1 h of t minus 8 plus t squared plus t squared h of t minus 3. This one, this is G1, is it? because we have no h here. How about these two? Which of these is g2 minus g1? Which of these, I mean t squared and t minus 1, which of these is g2 minus g1? This is 8 and this is 3. The smaller one is g2 minus g1. That means t squared equals g2 minus g1. That means g3 minus g2 is t minus 1. Okay? ليه السيكة بشو كتير لهجت بشو لبشو بيعب سرطاني من بو g1 أي g2 minus g1 شيء g2 minus g1 بريتيا لا coefficienti أو Herbicide function أكيد بشو كتيرين يعني Herbicide function h of t minus a أجر أكيد بشو كتيرين بو أوان g2 minus g1 جا قولته أبتشي g3 minus g قولته أبت g4 minus g3 بوشيوه أوكي فاتمرجنيه بهم بأوردري تايب نسيت برانتو سير كله بشوتين يعني كأفوي. This is converting a step function, a unit step function to a step function. Do you have any question about converting step function to unit step function and vice versa? Sorry. الشابتر اللي شو مداخلني بوم التيرم حتى higher order الشابتر يدو حتى الثاني higher order داخلني بس دوش داخله دوش شان سيكشن يصير داخل والله هو داخلني انه منحت We now have the Laplace transform of unit step function or the Herbicide function. You see the Laplace transform of h of t minus a equals to e to the power minus as. A is this number dividing by s. It's e to the power minus as dividing by s. So here we say the Laplace transform of h of t minus 2. It equals to what? Equals to e to the power minus 2s dividing by s. That's all. How about the Laplace transform of h of t minus 7? It equals to what? E to the power minus 7s dividing by s. That's negative. No, it's always negative. Look, it's negative. ايه كي قولت لي صفر ليه minus ام هي ايه كي قولت لي صفر ليه حاول تك قولت لي صفر يعني ناقص هي يا ساهي واسوبين حاول قولت لي صفر يعني here it means we must have no t minus 7 in this case less than 0. Okay, so that sign must always be negative. Okay, the sign must always be negative. Now we have the proof of this. So for the proof, we say the Laplace transform of h of t minus a is equal to the integration from 0 to infinity e to the power minus st h of t minus a, okay, dt. But the Herbicide function is a piecewise function. We say h of t minus a equals 0 for t between a and 0, and it equals to 1 for t greater than a. Okay, a here is itself, it's a. So you see it equals, let me write down it below. It's a piecewise function. So the Laplace transform of this function is the Laplace for that part and that part. You see, it equals to the integration from 0 to a. From 0 to a, this function is 0. From 0 to a, the function is 0. So this is 0 from 0 to a. 0 e to the power minus ast dt plus the integration from a to infinity. From a to infinity, the function is 1. 1 times e to the power minus st dt. This is 0. The result is 0 here. It equals to the integration from 0 to infinity, sorry, from a to infinity for e to the power minus ast dt. Now we take the integration for that function, e to the power minus st. Its integration is minus 1 over s times the function itself. It is the integration from a, sorry, we take the integration. It is minus 1 over s e to the power minus st from a to infinity. We first replace by infinity and we get 0 in that case, because here we get 1 over infinity. We have e to the power minus st. If we replace t by infinity, we get e to the power minus infinity, which is 0. It equals to 0 minus. Then we replace s by a. We get minus 1 over s e to the power. We replace t by a minus s times a. Equals to negative times negative is positive. It is 1 over s e to the power minus as, which is e to the power minus as dividing by s. This is the integration. This is the Laplace for the Herbicide function. That means from now, if we have a function like this, to find its Laplace, we don't need to prove this again. We just write down the results, which is e to the power minus as dividing by s. Here we have an example. We have the difference of two Herbicide functions. So the Laplace of this Herbicide function, you see the Laplace of f of t equals the Laplace of h of t minus 2 minus the Laplace of h of t minus 4. For the first one, the Laplace is e to the power minus 2s. Look, we applied this rule. We applied this rule. We just replace a here and nothing else. It's the same. E to the power minus as divided by s. And here a is 2, which is e to the power minus 2s dividing by s minus. And here a is 4, e to the power minus 4s divided by s, which is here the common denominator is s. Both have the same denominator, which is e to the power minus 2s minus e to the power minus 4s dividing by s. This is the Laplace transform for that unit step function. Okay, so let's take a break for 10 minutes. And we now have the Laplace transform of this form of the functions. If we have a function of f of t minus a, which is multiplied by the unit step function h of t minus a. The Laplace transform for this function is e to the power minus as multiplying by the Laplace of f of t. This is f of t. Okay, this equals to e to the power minus as multiplying by f of s. capital F of S. That means here we just find the Laplace transform for the function f, then we multiply it by e to the power minus as. Okay, that means if we multiply the Herbicide function or the unit function to a function f of t, we say we find the Laplace transform for f of t, then we multiply it by e to the power minus as. Let's take an example. If we have, let's say, the Laplace transform of t h of t minus 2, this equals to the Laplace transform of t is, here we have n is 1, n factorial, which is 1, dividing by a to the power n plus 1, which is 2, multiplying by e to the power minus 2s. Okay, this is a. We just multiply it by e to the power minus as. We find the Laplace transform for this one, and then we multiply it by e to the power minus as. Here, to prove this, we say the Laplace transform of, let's say, f of t h of t minus a. This equals to the integration from 0 to infinity for f of t times h of t minus a dt. But the Herbicide function, which is the unit step function, is equals to 0 when t is from 0 to a. It equals to 0 if t is less than a and greater than or equal to 0. And it's 1 if t is greater than a. Okay. Now we say it equals to the integration from 0 to infinity. Sorry, from 0 to a plus integration from 0 to infinity. From a to infinity. Sorry, a to infinity. For 0 to infinity, from 0 to infinity, you have f of t multiplying by 0 dt plus, for this one, this is e to the power. Here you have e to the power minus st. I forgot to write down that. It's for the rule of finding Laplace transform for a function. We should say it's e to the power, the Laplace transform for any function, let's say f of t, equals to integration from 0 to infinity e to the power minus st f of t dt. But here we have this function f of t times this. We multiply it by e to the power minus st dt, the integration from 0 to infinity. And this here also we have e to the power minus st f of t times 0 dt plus the integration from a to infinity e to the power minus st f of t multiplying by 1. Here h of t minus a is 1 dt. This is 0 because it's multiplied by 0. It equals to the integration from a to infinity for e to the power minus st f of t dt. Okay, f of t minus a. Sorry, I really forgot to write down t minus a here. Here you have t minus a times 0 dt. This is t minus a. As you see here, in above we have f of t minus a. F of t minus a, this is t minus a. This is also t minus a. You have f of t minus a, but we must find the Laplace transform for f of t. We must find the Laplace transform for f of t. What we do, we are gonna replace t minus a, let's say by u. We let u to be t minus a, and then du, we take derivative for both sides, we get du equals dt, because derivative of a is 0. And also here t equals u plus a, is it? Here we replace u by t minus a. We replace t by u plus a. If you move it to the other side, it becomes u plus a. And we replace dt by du. Let's see what we get. It equals to the integration from 0 to infinity for e to the power minus s u plus a. We replace t by u plus a. And here you have f of t minus a. It becomes f of u, because we said we let u to be t minus a. It is f of u du. Okay. And now we enter this minus s into the brackets. It becomes the integration from 0 to infinity. Sorry, from a to infinity, not 0. From a to infinity for e to the power minus as times e to the power minus su times f of u du. This is constant because here we have integration with respect to u. Here we have no u. We take 2 out of the integration. It equals to the integration from a to infinity, e to the power minus as. And what's left? We have e to the power minus su, f of u du. We said if we have the Laplace transform of, we said the Laplace transform of f of t equals the integration from 0 to infinity. The integration from 0 to infinity for e to the power, st minus st, f of t dt. Okay, and this is the Laplace transform of f of t, is it? This is the Laplace transform of f of t, because in the Herbicide we have two intervals, from 0 to a and from a to infinity, and it equals to e to the power minus as times the Laplace transform of f of u. Okay, this is the Laplace transform of f of u, and this equals to, as you see here, you got the same. That means if you have t, if you have the Laplace transform of f of t minus a times h of t minus a, it equals to e to the power minus as multiplying by the Laplace transform of f of t. Okay, here t and u are both variables. So that's the result. Okay, and sorry. Which one? This one or this one? This one. Okay. Yes. Eh? لا ناتوان لبرو لقدان للقدان ناتوان بجد بس لبلاصات وين كي باشا اف اوف تي ترتي ما ليله نقاو اف اوف تي كمان تي ليله. Okay, so now we have an example. In this example, what we say? We say to find the Laplace transform for this function. A is 4. That means we are going to find the Laplace transform for this part, and then we multiply it by e to the power minus 4s. Is it? we say the Laplace transform of, I'm going to write down the rule here, the Laplace transform of f of t minus a times h of t minus a, it equals to e to the power minus as times the Laplace transform of f of t. Here, we should find the Laplace transform for this part, and then we multiply it by e to the power minus as, which is e to the power minus 4as. Let's find it. The Laplace transform of this part is the Laplace transform of f of t equals. Here, we expand the brackets. Equals the Laplace transform of t minus 4 squared. And this equals to the integration from 0 to infinity for t squared minus 8t minus 16 dt. Sorry, times e to the power minus st dt. Okay, we just expand these brackets. It's t minus 4 squared. Sorry. بابا يصير بجاجة هذه كان كينو أنجام كذا يقدر يبتواني ناقص شوية سكين. Okay. Here we find the Laplace transform of f of t, and it's equals to let's do this. It's easier. It's easier to do directly by applying the rules. We don't need to use the integration. The Laplace transform of t squared is 2 divided by s cubed. And the Laplace transform of 8t is 8 divided by s squared. And the Laplace transform of minus 16 is minus 16 divided by s. This is the Laplace transform of f of t. We say the Laplace transform of f of t multiplying by e to the power minus 4s equals to 2 over s cubed minus 8 over s squared minus 16 over s, all multiplying by e to the power minus 4s. This is the result. Okay? ليرة لابلاسي نقش كادو زينو شو معناه تي ناقص 4 دو جان جاكا كينو او من دزكت تي دو جان ناقص 8 تي ناقص شانس من دزكت زي شانس من دزكت this plus زي شانس دين لا بلاس هي بودوسينو لا بلاس تيرم بتجادوسينو انجام لا بلاس ضرب تشيكين يبقى تواني ناقص اي اس اي كمان تشيل لي شوار ضرب يبقى تواني ناقص شوار اس يكين امان جاب so this is the Laplace transform of f of t minus 4. Let me write down it, which is t minus 4 squared times h of t minus 4. This is the result. Okay, we just applied the rule here. We just find the Laplace transform for f, and then you multiply it by e to the power minus as. Yes, and for this one, you have cosine 2 multiplying by t plus pi over 2. Multiplying by h of t minus pi over 2. Here a is pi over 2. This is a. And you have cosine, the Laplace transform of cosine 2 times t plus pi over 2 equals the Laplace transform. Here we simplify this. We introduce 2 into the bracket to the angle. We get the Laplace transform of cosine 2t plus pi. Okay. Now we expand this. We expand this one, and it becomes, we say cosine a plus b equals cosine a cosine b minus sine a sine b. We apply this rule. Sorry. Yeah, it's a rule. Yeah, that's rule. That's a trigonometry function rule. The cosine of sum of two function, two angles, is cosine first, cosine second, minus sine first, sine second. And here, this equals to the Laplace transform of cosine t, cosine pi, minus cosine, so it's 2t, cosine 2t times, so it's sine 2t, sine 2t times sine pi. Sine pi is 0. So this term all becomes 0. Is it? And cosine pi, this is it. And this is 1. Negative 1, sorry. It's negative 1. We say it equals to the Laplace transform of minus cosine 2t. Okay. Now we find the Laplace transform of minus cosine 2t. For cosine, we say the Laplace of cosine at equals s divided by s squared plus a squared. And here a is 2. A is 2, but you have a negative sign also. It is minus s. This is that negative sign. Dividing by s squared plus 2 squared, which is 4. This is the Laplace transform of the function of f of t. So the Laplace transform of f of t is minus s divided by s squared plus 4. And then the Laplace transform of cosine 2 times t plus pi over 2. T plus pi over 2 times h of t minus pi over 2. It equals to the Laplace transform of f of t multiplying by e to the power minus as. Here a is pi over 2. It equals to minus s dividing by s squared plus 4 multiplying by e to the power minus pi over 2s. This is the result. Okay. Here we just found a, which is pi over 2, and then we found the Laplace transform for the function f of t, which is minus s of s squared plus 4. Now we have this example. We have only this example. It says a function f of t is defined by f of t, which is 4, where t from 0 to 2, and equals to 2t minus 3, where t is greater than 2. It says express the function f of t in unit step function and determine its Laplace transforms. Here, what we do, we are going to find the unit step function. This is a step function. We have g1 and g2. Okay. We say the unit step function f of t equals f of t equals g1 plus g2 minus g1 h of t minus 2. Is it? We just apply the previous rule here. We have only two functions. We say it's g1 plus g2 minus g1 h of t minus a. A here is 2. 2 is common between these two, so that's why we take 2. Now f of t equals g1 is 4 plus g2 minus g1. G2 is 2t minus 3 minus 4 minus g1. G1 is 4. H of t minus 2. So f of t equals 4 plus 2t minus 7 times h of t minus 2. This is f of t, and this is 4 only. We take the Laplace transform for this function. The Laplace transform the Laplace transform of f of t equals the Laplace transform of 4 plus 2t minus 7 times h of t minus 2. Okay, the Laplace transform of 4 is only a constant. It's the number divided by s. It is 4 over s. And the Laplace transform of this function is multiplied by the unit step function. We find the Laplace transform for this part, and we multiply it by e to the power minus 2s. Okay, because here a is 2. This is a. We say it equals to the Laplace transform of 2t is 2 over s squared. Is it? 2 is the constant, and the Laplace transform of t as the exponent is 1. You say 1 factorial divided by s to the power 1 plus 1, which is 2, minus 7 dividing by s. It's a constant. This equals to e to the power minus 2s. Okay, this is the Laplace transform for that step function. And here we found the unit step function, the unit step function. This is answer for the first question. It says find the unit step function and then find its Laplace transform. This is the Laplace transform. Baba. See, step function بشوي piecewise function that. I'm a step function. But a unit step function is yeah. Vale, بشوي يك function unit step function. باشا. but I'm دلالة شيء يشكل. الصفر ويك. يا صفرين. لأن الصفر وبودو صفر. لدو جورة اليك. باشا. أجا إيش تبغى unit step function. بلام أجر هل بمشي ويبو بشوي نخشيعي. تيجي step function. باشا. بمشي convert. Okay. You say the Laplace transform of a times f of t. I'm gonna apply this rule. It equals to a times the Laplace transform of f of t. Let's return to the rules. Let me write down the rule here. We say the Laplace transform of t to the power n. It equals to n factorial dividing by s to the power n plus 1. Yes. S plus 1. N plus 1. Okay. Here we have t. We have 2 times t. Okay. So you have the Laplace transform of 2 times t. It equals to 2 the Laplace transform of t. Is it? And this equals to 2 times s power is 1. 1 factorial is 1. Dividing by s to the power 1 plus 1 is 2. Was 2 over s squared. That's it. And here you have minus 7. Minus 7 is a constant. We say the Laplace transform of a constant is a over s. It's minus 7, so you say it's minus 7 over s. Okay. And this part is multiplied by this unit step function. That's why we should multiply it by e to the power minus 2s.